Hello, everyone. You are welcome to today's meeting. And in today's meeting, we are going to draw the curtains down on the solution to the Nigerian WASSCE 2024 for core maths. Okay, remember we have so far dealt with, I think almost all the questions. We took out only the circle theorem questions, and I said that will be the last set of questions that we will look at on, or yes, in that word, exams, on that exams paper. So quickly, let's look at the first circle theorem question, which happened to be question number 4. Okay, so we are going to analyze together before we look at how best to put your presentation, because I saw that in your presentation most of you did not attach your reason, which I advise you to. Anytime you state a theorem, put your reason in brackets, but most of you forgot to do that. I don't know whether it was intentional or not, or maybe you thought it wasn't necessary. Okay, so please, this is it. Okay, so with this diagram, I've intentionally extracted it, huge here. We have, we are told that O is the center. So this is the center. Let me use the, O is the center. Okay, and we know this angle to be T, that is angle bad to be T, angle ADO to be equal to angle OBA to be equal to Y. So these two angles are equal and they are equal to Y. Okay, and we are also told, if you read the question, we are told that OBCD is a quadrilateral, but that is a rhombus, a special quadrilateral. So this rhombus must be underlined. Okay, so once you see this special figure, this quadrilateral there, then it means we basically want you to make use of properties or angle properties concerning rhombus or a rhombus. So please, take note. So now let's go and do the usual stuff. And I've told you, you should always plan. Okay, go and do your rough work, do your analysis in the diagram, or on the diagram, then later, that is you planning. Later, you execute your planning by, presenting it in your, solution. Okay, so now what do we do? Okay, we are told that if you look at this, this is the center, and you have an angle at the circumference. So this should tell you that, I know a connection between an angle at the center and the angle at the circumference, for cos and arc, same arc or same chord. So it means if for nothing at all, we all agree that the angle here, is supposed to be twice the angle at the circumference. So this should give us what? 2t. Do you agree? My
Yes.
professors, do you agree? You agree, right? Okay, very
Yes.
good. And we are also told that this figure that we have here is a rhombus. So for a rhombus, we know that opposite sides are parallel, and you know all the properties anyway. And I am more interested in the angles. And we should also know that the opposite angles of a rhombus, should be the same. So this angle and this angle should be the same. So that should give us 2t as well. Should I come again or my point is well made?
Yes. Correct.
I should come again.
Yes.
Okay, so we know when it comes to a rhombus, these are the basic properties that you should know concerning a rhombus, because we are told that this figure that we have here, is a rhombus. This figure, let me see, I think the cursor, so this figure here is a rhombus. We are told OBCD, so OBCD here is a rhombus, that quadrilateral. And we know the opposite angles of a rhombus are what's equal. Okay, however, adjacent angles are supplementary. You remember all these properties, right? So
Yes.
without these properties, you wouldn't be able to sail, smoothly. Okay, so it means if for nothing at all, I know that the angle here to this angle, the entire angle here, if I sum this angle, because these two angles are adjacent angle, this and this are adjacent, this and this are also adjacent, this and this are adjacent. So if I sum these two angles, they should be, I should have what? 180. So it means if for nothing at all, I also know that this angle here is 180 degrees minus 2t. Do you agree? My professors, do you agree?
Yes, please.
Okay, in the
Yes.
same way, so this angle here and this angle in this what rhombus, you should know that they will also be equal. So it means this angle is also known because it will be the same as this angle. Okay, however, now let's see how useful that will be. We also know that opposite angles, okay, of a cyclic quadrilateral, you can see the cyclic quadrilateral A, B, C, D. Opposite angles of a cyclic quadrilateral, okay, must give us what? 180. So it means this T plus this T, sorry, that 2T that you have here should give us what? 180. And if you form that equation, it will be an equation in T, then you solve for that T. Is that clear, my professors?
Yes, please.
Okay, all right. Okay, or okay, so now again, can I also say, please listen carefully. If you look at this, remember when I was teaching you circle theorem, I remember I gave you this simple information. Okay, that if you have something of this sort, oops, okay, the picture is not coming out clearly. Okay, so let me, okay, I think this. Okay, the angle here, okay, is the angle related to this one. The angle you can see two angles at the circumference. This angle here and this angle. You can also see two angles at the center, provided this is your center. This angle and the reference angle here. Do you agree?
Yes.
Okay, remember I told you that the angles with the same directions, okay, will be the ones that are related. So this center angle here and this circumference angle, this center angle and the circumference angle here, you can see that the arcs are in the same direction. So it will be these two angles that are related. And in the same way, this circumference angle and this center angle will also be related. Okay, that's where you get the center angle being twice the circumference angle. Is that clear?
Yes.
Okay, so I'm more or less, instead of going, I'm doing all the analysis to bring out all the theorems that possibly you can use, because remember I said we'll use today as a source of revision. So now what do we do? So it means if I know that this is 2t, this angle here is 2t, I should know that the reflex angle here will be twice this angle, which will give us what? 4t. Do you agree? My professors, do
Yes.
you agree?
Mm.
You are quiet. So what is happening? Do you agree?
Yes,
Respond. Okay, let me.
please.
We're analyzing together. So if you have issues, okay, remember it should be interactive. If you have any issues, okay, or anything that I say that maybe you think is contrary to what you already know, bring it out. We will negotiate understanding and we move on. Okay, so once we have done this, now let's see. We are asked to find angle, the value of t, sorry, the value of y and angle ADC. So the angle that we are interested in is angle ADC, the entire angle here. And you can see that based on the analysis that we have done here, if you are able to find y and we are able to find what t, we know the entire angle here. Because the entire angle here will be y plus 180 degrees minus 2t. So if you know y and t, you can know the size of what this angle. Afa,
No, please.
okay. Did you say yes?
Stefan, please,
Yes,
can you
please.
go over
Come
the
again.
fort? Can you please go over how you got the 40?
Oh, all right. So you can see center angles. Anytime you draw, if anytime you have something like this, you have a center and you immediately you draw, okay, what do you call an arc, subtending a certain angle at the center. You always have two angles at the center. This angle and the reflex angle here. And remember I told you that if you are referring to this angle, you qualify that one with what reflex angle. So I can say maybe if this is A and this is O and this is B. Okay, if I say angle AOB, then I'm talking about this angle. But if I'm referring to this angle, then I have to say reflex, okay, angle, okay, AOB, then it means I'm talking about this angle. So angle AOB, we have two. Okay, this small one here and the reflex one. But if I don't qualify it with reflex, then it means I'm referring to this one. Otherwise, I have to qualify it if I'm referring to this one. Is that clear? So it means indirectly you have two angles at the center. But circumference angle, okay, so if I draw my, I get, okay, circumference angle here by the same arc or chord. Okay, you can see that I have a circumference angle here, only one circumference angle, but I have two, okay, center angles. So in this case, which ones will be related? Because I have the reflex center angle and this was center angle. And we said the relation is between the ones moving in the same direction. So this arc here, okay, and this arc, you can see that they are moving in the same direction. It's like this and that, they are moving in the same. So it means it will be these two, okay, angles that are related. One being the center and it corresponding, okay, circumference angle corresponding the sense of the arc, the nature of the arc. So it will be this center angle that is twice the circumference angle here. So this angle that is here, I can also say I can do this. Immediately I do this, I have another circumference angle. Do you agree?
Yes, please.
Okay, this circumference angle, okay, is related to this center angle because the arcs are in the same direction, this and that. You get my point. So it means this center
Yes, please.
circumference angle and center angle here will be the one that will be related, the reflex center angle. So again, you know that the center angle, okay, is always bigger than the circumference angle. However, it's twice bigger. So if I know this angle, I know this as well. Is that clear?
Yes,
Or better
please.
still, if you're able to get the value of t, okay, and you know the size of this angle, this you can use the angles at the center. Subtract this one from t60, you get the same result. If you like, when we find the value of t, okay, you will see that if you multiply the t by 4, you will get the same result as you subtracting the 2t from 360. Point well made, my professors.
Yes, please.
Okay, so once that we've done the analysis and you appreciate, okay, the analysis, can we go and start our presentation?
Yes, please.
Okay, all right. Okay, only one person is responding. What is happening? Please respond though. Okay, circle theorem there. You know that that one is a banker. That's the more reason why I'm treating that one, okay, alone. Because no matter how, okay, you pray, circle theorem questions will come. Again, circle theorem, it will come. Okay, all right. So now, if that's the case, then let's go and look at how best to put our presentation. That is key. So, solution, that's the first thing that you write. Okay, after solution now, okay, we know that the center angle here, that is, we know that, and, okay, so I'm looking at, okay, so the question number 4 will come. Okay, and BOD, angle board, we know will be equal to twice the angle at the center, and that is angle bad. Okay, so this implies that angle BOD, okay, will be equal to twice which angle? The angle T. Is that clear? But remember, I've told you, immediately you state the relation, don't forget to give your reason, okay, for that relation in brackets. So immediately you forget that, okay, sometimes you lose the entire mark or we deduct certain marks. So in this case, we are going to protect our marks. So you can write just center, like I told you, center and what? Circumference angle, as simple as that. Is that clear?
Yes,
My
please.
professors, are you with me? Okay, so at this point we know that, okay, BOD and the BOD is 2T. Remember, we've done the analysis, so we know the way we are going to go about our argument. So again, we know that this 2T, okay, plus, okay, so let me even come here because it's this 2T that I'm supposed to use plus this, not this one. Okay, so we should know that because angle quadrilateral B, or is it, how did they name it? It's OBCD. Okay, it's a rhombus. We know that the opposite angles must be equal. So in this case, I can also say that angle BOD, okay, should be equal to what? Angle BCD. What is my reason? My reason is opposite, okay, angles of a rhombus. Okay, they are, oops, I did not say the rhombus, forgive me. Okay, opposite angles of rhombus are equal, and that's what you stated there. So it means, okay, this will also be equal to what? 2t. Okay, so in this case, I can say that this implies that angle BCD, okay, will also be equal to 2t. All correct. Okay, however, I also know that I need to form an equation in T. This angle here and this angle, okay, if I add, I should get 180. That is opposite angles of a cyclic quadrilateral. And I told you they're the same as angles in the opposite segments. Okay, so if you see your chord, you will see that this is in one segment, this also in another segment, they are supplementary. So your reason, you can use the cyclic, okay, quadrilateral, or you can use the opposite segment one. So I can also say, but, okay, and bad plus this angle BCD, okay, should be equal to 180. What is my reason? I've stated the relationship. My reason, I put it in bracket, and the reason is that, okay, I can write angles in the opposite, okay, segment, or angles in a cyclic quadrilateral. So I can write opposite segments. Okay, or put in brackets, or you can use the cyclic quadrilateral like I said. So in this case, I can say that this implies that, okay, bad is what is T plus angle BCD is 2T, should be equal to 180. So in this case, I'm going to get 3T is equal to 180. Don't forget your degree, so all along. You write it again before you divide. My professors, I hope you are following. Okay,
Yes.
over 3. Okay, so let me see if I can create another, okay, so let me pause, then create. It didn't go there. I don't want to come and squeeze it here. So definitely I will need, okay, one more. So let me pause, create another slide for the continuation. Okay, so what we are doing is for the A. Okay, so we'll come and normal our solution accordingly. Don't worry at all. Okay. Okay, so now we can have created the, okay, slides for the continuation. So where were we? Let's look at where we were. So we were looking at, okay, we said, let me go over here. So we were looking, so now we are finding T. So T will be equal to what? 60 degrees. Do you agree?
Yes, please.
So you are going to get, okay, T, so I found my T, therefore T is equal to, that's T, okay, there is no angle, I mean degrees there, so I can write, okay, 60 degrees. Okay, so if T came with degrees here, then you write T is equal to 60, you know that. So what I've done here, in fact, the way I started, I was looking for my A, which is the solution for A, which is the T. So I can come and write, okay, A here. So where I started, I was looking at A, solution to A. All right, so now I'm moving on to B. Is my point well made, my professors?
Yes.
Okay, so B, we are asked to find Y. So you know that when you are moving from A to B, you leave a line. Okay, so if we are asked to find Y, then we need to equally generate an equation that will contain, okay, either only Y or Y and T, because you now know T. Okay, so for me, this is what I'm going to do. Okay, if you want to use, okay, the 4T here, okay, then it means I want to generate an equation using this quadrilateral. Are you with me? Is my point well made?
Yes,
Okay,
please.
someone can also say that once you know, okay, you know which size. Okay, so once you know the size of this angle here, okay, which is 180 minus 2t, and it's in terms of t. Okay, so you know the exact size. We are analyzing. Okay, if you're able to find this exact size, you know, because this is a rhombus, the diagonals will bisect the angles, the opposite angles. So it means if I know the entire angle here, I know the small angle, I know the small angle. Okay, you know that these two small angles should be the same. Again, this being radius, radius, so isosceles triangle. But I don't want to go that route. I want to use this one too and see whether we end up getting, because most students will go that route. This is an isosceles triangle. The angle here should be equal to the angle here. And the angle here should be half, okay, the entire angle here. Is that clear?
Yes.
Okay, so but I will not go that route. Okay, so I'm going to go this direction. So I can say that, and okay, B, okay, so I think it's rather reflex angle. Okay, angle BOD, BOD. Okay, will be equal to twice this angle. Okay, twice angle, this angle you found, angle BCD. Okay, and again, you are using center and circumference angle. Point well made.
Yes, please.
Okay, so it means, okay, this, oh, what did I write? Is equal to, to rather be twice. Do you agree? So it means originally you were not following. Okay, center and circumference angle. So this implies that this reflex angle will be equal to what? Okay, twice, okay, 2t. Okay, which will be equal to 4t. Okay, but, okay, your okay, instead of let me write it in terms of angles so that when I substitute, you can easily relate. But angle bad, okay, plus angle, so this angle T plus angle ABO. Okay, so angle ABO. Okay, okay, BO, which is your Y. Okay, plus the other angle here, which is angle ADO, angle ADO. Okay, plus this is your reflex angle. So reflex angle, okay, BOD. My professors, I hope you are following. Should be equal to 360 degrees. Okay, angles in a quadrilateral. Is that okay? My professors, are you with me?
Yes, please.
Okay, very good. Okay, so on that note, I'm going to get this implies that angle bad, you know, is T. Okay, I will later come and substitute the corresponding values. Then, okay, plus, okay, what do I have? Angle bad. Angle bad is what? Oh, bad is what we have done. ABO. ABO is Y. Okay, plus angle ADO, which is also Y. Then plus and reflex angle BOD, and that is 40. Okay, will be equal to what? 360 degrees. Okay, so at this point, you can either substitute now or you simplify before you substitute. Okay, I'm going to simplify before substituting. So I will get, okay, 5t plus 2y is equal to what? 360 degrees. Don't forget your degrees, okay, at every stage. So now this will give you 5, your t, you know, okay, and that is 60 degrees. Okay, plus 2y should be equal to what? 360 degrees. My professors, I hope you are following.
Yes,
Okay, so now at this point, okay, we continue, and if you go back, you know that we are going to get, okay, 5 times 60 will give us
300.
come,
300.
come again.
300.
5 times 6 will give you what? Then you attach your, so it will be 300.
300.
Okay, so we are going to get 300. Okay, this implies that 300, okay, degrees. Let me see whether I was supposed to bring degrees somewhere that, yes, this is 60 degrees, so don't forget. Okay, so Now you are going to get plus what? 2y. So plus 300 plus 2y is equal to 360, okay, degrees. Okay, so at this point you get 2y to be equal to 360 minus 300. So that will give us 60 degrees. You write it again before you divide. Okay, 60 degrees over 2 over 2. So therefore, y will be equal to 30 degrees. All correct. Okay, so I think
Yes.
the two I presented, if you remember, I put three of you, your solutions there. The last two, you had 45, 45 for the first one or so. Okay, but the first one, what happened to be Stephanie, had the 60 and what, and now the 30 that we have here. Okay, so we know why. Okay, once you know why, indirectly we know, okay, this, okay, size of what? Angle. Angle B, what? AD. So now let me, is it angle ADC? That's what we are looking for. So I can say that angle ADC, that is C. Angle ADC, you know, is made up of, is equal to this angle here, which is y. So angle ADO, aka ADO, angle ADO, okay, plus this angle here, the entire angle here, angle ODC. So angle ODC. Do you agree, my professors?
Yes, please.
Okay, and this one, there is no property, it's just a relation. You could see the angles there. So you don't give any reason. Obviously, you can see that the entire angle here is made by this angle and this what angle. But remember, we did this analysis here, but we've not, okay, given any solution, okay, for this particular one. So I will come go and write, you know this to be y, but you don't know this. I'll go and write, but how did you get this angle? Okay, we said that this angle here, angle ODC, okay, should be equal to 180 degrees minus what? Angle, okay, what do you call it? BOD. BOD. Or you can say the angle ODC, okay, plus angle BOD should be equal to 180. And that would be adjacent angles of a rhombus. So, okay, adjacent, okay, angles of a rhombus. But professors, I hope you are following.
Yes.
Yes,
Okay,
please.
so it means your angle ODC will be equal to, okay, so I will come right close to the margin, will be equal to 180 degrees minus your 2t. Okay, so that's what you have there. So once I know this is in y, this is in what? In t. I can now go and substitute. Then I know the values of y and t. We are good to go. Okay, so with this one, I'm going to continue here. Okay, unfortunately, I don't want to go and create. So assuming it will be better, I do create that. So let me quickly do that so that the presentation will be neat. Okay, all right. Okay, so we have created another slide to contain the continuation. So, Prof. Akosia, you said you wanted to ask a question. Should I go back?
No, please, the diagram is still there. I was wondering why angle BCD couldn't be 180 minus 2t.
Angle,
One
which one?
angle
This
B,
angle.
yes, please.
You were wondering why it couldn't be. No, you see, when we are talking of rhombus, okay, rhombus, the opposite angle. If you say that, okay, if you want to write, if you want to write that, then you have to write 180 not minus 2t, but it will be 180 minus t.
Yeah.
You get it? That is,
Yes,
if you are
please.
using U, then it means you are using the opposite angles of a cyclic quadrilateral. And if you do that too, you end up getting the same value for t.
Yes, please.
You get it? So if you come and write 180 minus 2t, it will be wrong. Then it means you are assuming that the angle here plus this angle should rather give you 180. No, they should be the same. They should be equal because we are talking about a rhombus.
Yes, please.
You
Thank you.
get the point? Okay, you are welcome. All right, so now I think we are in a comfortable lead. We are almost done. So let's go to what we have there. So now that we have picked this one out, okay, Prof. Ann.
So please, I wasn't hearing what you were saying at first. I wanted to ask what the
You were
360
not
plus
here.
was. I was saying about my network was not like
Okay.
stable, so I wasn't hearing what you
Lucky
were saying
you.
at the I joined from the ADC pass, but I want to understand where the 360, the top one part, 360 plus 2i is equal to 360. Please, where is it
No,
from?
it's not 360. That can 360. It's 300.
3.
100. It's coming from here. 5
Okay.
times t, which is what, 60 degrees. Okay, that's
Okay.
300. Okay. You want to tell me that my
Thank you.
handwriting is not legible? I won't mind you. All right. Okay.
Thank
So this is what we have. So let's move on. So we took this one out because we don't know. That's why we wrote but. Okay, we've taken it out. It has interfered. So we cannot come and write equal to then place the but. Once something has interfered with what you are saying is equal to this, you need to write this side again. So I'm going to write that side again. However, I can start with therefore because I will conclude with that. So I'll write therefore my angle ADC, okay, will be equal to, now let's go and look at what we have there. Okay, it will be equal to, we said ADO, and ADO is y. So it will be y, okay, plus 180 minus 2t, just as you can see in the diagram. So it will be y plus 180, okay, degrees minus 2t. Okay, so you know the values of y and t. So this will be equal to, okay, y, what did we get? We had was 30 degrees. So 30 degrees, okay, plus 180 degrees, then minus what? 2t. And 2t is what? 60 degrees. So now you are in a comfortable lead. So you get 30 degrees. If I like, I can even write 210 degrees here. I can add this to 210 degrees, then minus what? 120 degrees. Okay, so what would that give us? Hello, what would that give us? My professors, are you there? Can you hear me? I hope I'm recording. Have I resumed recording? Okay, yes, I'll hurry up. You know I don't do this calculation. Oh, give me the value, this one
90.
there. Hey, 90 degrees. Okay, so that will give you what you have there. So let me, okay, so 90 what degrees. So we are done. Okay, so that will be it for what we have, okay, here. My professor, is the explanation okay? Okay, somebody can also represent this by a letter and say that maybe this angle here is equal to this angle here. And therefore, once you know T, okay, that angle which is represented by a letter will be equal to 180 minus the whole of this, okay, divided by 2. Then you give, okay, 1 to each of what you have there. Then after that, you come and use, okay, and what you have here, the angle here is the same as this. So any angle that we get here, okay, its corresponding angle will be here. So because this line will bisect this one. If you draw a line here to it, you equally bisect that because the diagonals will bisect the opposite angles. Okay, all right. So now, okay, we are going to move on to, okay, the 12. Okay, are we fine, my professors? Oops, I couldn't use 1 hour. Okay, so maybe this one, I think I'm not going to do the presentation. I will just, okay, guide you in terms of how to do the analysis. Okay, give you the presentation. Anytime you state a relation, then okay, I will do the second one. Let me see the third one. It's similar. The third one is very easy. So let's do this one. Okay, a lot of lines, but don't worry. So here, anytime you read, okay, a circle theorem question and you see a tangent, just one tangent, then you have to know that you are supposed to use that theorem connecting tangent, a tangent. We have another one connecting 2 tangents. Okay, so the one connecting, okay, a tangent, you remember, okay, we said if you have this, usually there will be, if I have a tangent, okay, first of all, a center, the radius and the tangent will meet at an angle of 90. That is one. And another theorem connecting tangents will be where you have a triangle sitting on it with all the vertices at the circumference. Okay, in that case, okay, what we call the alternate segment angle. The angle here will be equal to the angle here. So the angle between this chord and the tangent, okay, is equal to the angle that chord makes at the circumference. Okay, so it means if I take this angle 2, okay, which is the angle between this chord and the tangent, it should be equal to the angle this chord, okay, that is making this angle with the tangent, makes at the circumference, and that will be this angle. So these two, if this is x, this will be x. If this is y, this will be y. All correct. So anytime you see a tangent, check whether you have a radius meeting it, any line moving from the center to meet it. Then it means it will meet it at an angle of 90. Or check if you have a triangle sitting on it with all the vertices at the circumference. If you look at this, you can see that this tangent that you have here, let me use them. This tangent has what? Two triangles sitting on it. TOQ, triangle TOQ, and triangle TSQ. Do you agree? However, triangle TOQ doesn't have its what? All the vertices at the circumference. You have one of them at the center. So it means that one, the theorem will not work for it. Okay, the alternate segment angle will not work for it. The other triangle TSQ, you can see that that triangle, all the vertices are at the circumference. So it means you can use that one to bring out the angles in the alternate segment theorem. Is that clear?
Yes, please.
My professors, are you with me?
Yes, please.
Okay, so this is it. If for nothing at all, I know that this is a radius, so the angle here will be 90. Okay, we are doing the analysis before. I've told you, do your analysis before you go and present. Okay, so that your presentation will be very coherent. Okay, so now, again, you know that the entire angle here will also be 90. The entire angle here, this is 90, that will also be 90. Okay, so let's see. Obviously, you can see an angle at the circumference. Okay, an angle at the center, forgive me. And that angle is subtended by this arc TQ or chord TQ. But this same arc or chord TQ is subtending another angle at the circumference. Can you see that? So it means the center angle and the circumference angle here, you see that they are arcs. If I need to indicate an arc here, the arcs will be in the same direction. So these are the two related what angles, center and circumference angle. So the angle here, I know will be half of this angle. Okay, so half of this angle will be half of this angle will be 28.
Yes, please.
Okay, so this angle is 28 degrees. My professors, I hope you are with me.
Yes, please.
Okay, so we are looking for the one that we can easily find. Okay, then later we go and use our analysis to find whatever. So again, remember we said this is the triangle that will bring in the alternate segment, okay, theorem. Okay, so there's the triangle. So you can see that in that triangle you have a chord here. Okay, Prof. Akosia.
That one, please, and what you just did, can't they be angles subtended by the same chord?
Yes, it's the same chord, but one is at the center, one is at the circumference.
And I thought those angles, they were equal.
Hey, center and circumference.
No, not center and circumference. Angle subtended by the same chord at the same segment.
At the same segment.
Yes,
Which
like
angle?
when
No, you can see that this is the one that will be equal in the same segment. They will all be at the circumference. But you have only one angle here at the circumference obtained by this chord. If you had another angle here, okay, at the circumference, then you can see that these two angles will be the same. Of course, still your circle theorem is not theorem. How many angles at the circumference can you see subtended by the chord TQ?
it's just one.
One. So the one in the same segment, we are talking about, okay, angles at the circumference in the same segment, okay, by the same arc or chord will be equal. Okay, angles at the circumference in the opposite segment. So it means the two angles that you are comparing, they should all be at the circumference. But if all of them are at the circumference and they are in the same segment, that's where they are equal. If they are in the opposite segment, then they will be supplementary. Do you get the point? But when the chord is obtaining an angle at the center and one is at the circumference, they are never equal because the center angle is always bigger than the circumference angle, but it's twice bigger.
Yes, please.
You get it? So this cannot be equal to 56. Obviously, this is at the center. Okay, so if you had this to be at the circumference and it's the same segment, because if you take this chord, okay, this is one segment, which is the minor segment, and this is a major segment. So if this is here, it's in the major segment. If this is here, it's also in the major segment. So we'll say that they are equal. But this is not at the circumference, it's at what the center. So you cannot say they are equal. The angles that you are comparing are not all at the circumference. You get it?
Yes.
Okay, very good. Okay, so if that's the case, then I guess I can go and clear, okay, the lines that I introduced there just to, because my analysis that I'm doing, I don't need it. Oops, okay, so we are good to go. So let's do the analysis together. I don't know whether time will allow me to present. Okay, so now, okay, we are saying that this chord, okay, this chord that we have here is the chord subtending this angle. Okay, so let me pick this. This chord that we have here, okay, let me use this. Is the chord subtending this angle at the circumference S? Do you agree? Is this chord that is subtending this angle? But this chord is also subtending an angle, okay, did I say making an angle, okay, with your tangent? Do you agree? This and this. So it means the alternate segment, this angle here will be equal to the angle that we have here. So it means this angle that I have here will equally be 28 degrees. Is my point well made, or I should come again?
This one.
I should come again. Remember, so indirectly, if you remove the other lines there, this is what we have. The angle made by this chord. So if I have this, remember what I was saying initially. It's a good theorem. I deal with the interpretation of, and I'm still talking plenty like that. Okay, so this is it. Okay, so you should have a triangle resting on your tangent for the alternate segment angle. So if I know this angle, I know this angle. Because this is the angle between the chord and the tangent. It should be equal to the angle that chord that is making, okay, an angle with a tangent makes at the circumference. So this chord is making this angle at the circumference. So if I know this angle, I know this angle. If I know this angle, I know this angle. In the same way, if I take this chord and the tangent here, okay, this chord and the tangent, they are making this angle. This chord, okay, is making a certain angle at the circumference, and that's this angle. So if I know this angle, I know this angle. If I know this angle, I know this angle. Is that clear?
Yes, please.
Okay. All right. So now that is exactly what I have here. So if you take this, okay, this chord is the one making this angle at the circumference. So that angle should be equal to the angle, okay, between that chord and the tangent. So this. So in the same way, if I come and take this chord, this is the chord here. Okay, the triangle. So you can see that this is the nature of your triangle. Okay, so if I take this chord and the tangent, okay, this chord that I have here, okay, this chord is making this angle with a tangent. So if you want to know the angle that will be equal to this angle, okay, in your triangle that we have here, it will be the angle subtended by this chord at the circumference, and that will be the entire angle here. Is my point well made? You get the point? Now, Professor, are you with me, or I should come again?
Please come again.
Hey,
Please come
then
again.
they need the test with the exams when you're here. I've seen your plans all. All right, okay, even if it will eat into midnight, we'll write it. All right, okay, so this is what we have. Okay, so it's just like what I just, only that the picture that we have there is the same thing. Okay, don't be confused. So this is the picture now. Okay, this is not, okay, this is the picture. It's something like this. Oops. There's a picture now. Don't you have a triangle resting on your tangent? with all the vertices at the circumference.
Yes, please.
Okay, so I've taken out all the disturbing lines, okay, the lines that is supposed to, okay, disturb. So here, if I have this is the angle. You can see that I have, how many chords do I have here forming my triangle? Is it not 3 chords? But the 3 chords, always two of the chords will make an angle with the tangent. So if I take this chord is making the angle with the tangent here. If I take this chord is making the angle with the tangent. This chord has nothing to do with this tangent. It's not meeting it, so it cannot make an angle with the tangent. Is that okay?
Yes, please.
2 chords, 2 angles with a tangent. So at this point, if you want to know the angle that will alternate, okay, will be in the alternate segment, take the chord that is making that angle with a tangent and look at the angle that chord is making at the circumference. So this chord is making this angle here at the circumference. So this angle here should be equal to this angle. If you come and take this chord, okay, this chord that you have here, the angle that is this chord is making this angle at the circumference. So always the 2 angles that you will be considering, they will have, okay, it will be the 2 interior angles of your triangle, okay, having nothing to do with the tangent. So you can see that the other interior angle here has something to do with the tangent of the triangle. So always, and if you look at this, okay, we never consider this. Always it will either this which is equal to this or this which is equal to that. As simple as that. So it's the same thing that is here. So the angle here is what we can see here, and that must be equal to this. Is my point well made now? My professors, are you with me?
Yes, please.
All right. Okay, so now this is what we have. We are analyzing. Okay, bringing before we come to this. We are making use of all the possible theorems here. So indirectly, I've catered for the 90, this angle, and this angle. Again, okay, you know that once you see triangles in play, okay, then it means possibly the question wants you to also make use of some angle properties of triangles. Okay, as well. So if I take this is a radius, this is a radius. So if for nothing at all, I know the angle here, the angle here. Okay, let me, I think it will be better. Oops, forgive me. Okay, I think it will be better for me to use different, okay, pens, right? Okay, I think so let me use different pens to draw home my point. Color. So the angle here, okay, will be equal to the angle here. Do you agree? If you take this triangle TOQ, it is an isosceles triangle. So which you know one of the angles. So you subtract this one from 180, subtract this from 180, divide it by 2, then you share. Then you know each of these angles. Is my point well made? Hello, my professor, is my point well made?
Yes, please.
Sir, please can you go back?
Okay, from where? Okay, I said you can see that if you look at triangle TOQ, this is a radius, this is a radius. So you don't need a rocket scientist to tell you that the length of TO or OT is the same as the length of OQ. Therefore, this triangle OTQ, okay, is an isosceles triangle. So the base angles here should be equal. And the base angle, one runs from here to this line, and the other runs from here to here. You get it?
Yes, please.
Okay, so that's so easy. Okay, as well. So it means indirectly, once you know the size, these 2 angles, you know them. Okay, subtract this one from 180. So it means this angle would be 180, okay, minus 56 divided by 2. That will give you the size of this angle, and therefore, which is equal to this angle. All correct. We will not come to the presentation. Oh, please take notes. Okay, we are just exploring, okay, making use of all the necessary then before we come to the question on how to deal with it. Okay, so now let's see. Can I make use of any? Okay, all right. Let me see if I know. Okay, we found this. We know that this must be equal to this. Okay, however, how do I find this angle? Okay, now, okay, I think we've done enough of the analysis. Okay, so again, I can say that if you know this angle here, you know this angle. And once you know this angle, okay, I'm talking about you knowing this angle, you know the small angle here, you also know this angle, angles on a straight line. Okay, vertically opposite, is it? Yeah, vertically opposite angles. Okay, this will also be equal. And once you know this angle, you know the small size angle here as well. So you just play with it. Okay, anyhow, anyway. Okay, circle theorem questions are interesting questions because it's okay exposes you to okay how best you can do it. And I've told you that you have a whole lot more of ways of presenting, only that one of them will be ideal. So now let's go and look at what we are looking for. Okay, Prof. Ann.
I wanted to ask if, like, at the beginning, instead of using chord um TQ, can T also be looked at as a chord, or it's not a chord?
What is a chord? Can what be looked at a
CO.
chord? TO. Are you asking what is a chord?
Line that divides a circle.
A chord is a line that divides a circle. A chord is a line that runs from one part of the circumference of a circle to another part. So the end point of your chord should all be at the circumference before you call it a chord.
Okay.
Mm-hmm.
Okay.
All right. Okay. So I'll come for 50 Ghana cedis for doing this
So
to
please,
me
so
to buy pressure drugs. Oh, feel free. I'm like that. Don't mind me.
so
Ask me your
can
questions.
we say CO is making um
See what?
um
TO.
CO?
No,
Yes.
TO is not a chord. Okay, when you talk of
Okay.
the angles subtended, you are supposed to talk about cause and act. TO is not a chord, it's not a act, it's neither a chord nor an act. So you
Okay.
cannot use, the theorem is about cause and act.
Okay. Thank
Okay,
you.
and tangents, all right, so you cannot. Okay, all right. Okay, so at this point, okay, let's go and look for the angles, the actual angles that we are looking for. So angle T, is it T? QP. Is it TQP? I guess so. So angle TQ, okay, P. So we are looking for this angle. Okay, that one, we found it. So it means we have given the solution to this, is that not it? Already. Because we found this knowing this. We said that this angle and this, so we use the, okay, so let me present the solution so that you can relate. Okay, so let me change the color and go to my usual red. Okay, so solution. Okay, we are going to look at, okay, I. Okay, but before, so I will say that I. Okay, so now am looking for angle, okay, TQP. I know TQP is equal to this angle here. Okay, but I will later go and find it, don't worry at all. It's equal to this angle. Okay, so where is it? Oops. This angle here, because we use the angles in what the alternate segment. This chord, okay, is making this angle with a tangent, and it's this chord that is making this angle at the circumference. So I will write is equal to angle TSV. Okay, TS what V. Okay, what is your reason? Your reason being that, okay, alternate angles or alternate segments, angles, alternate segments, okay, angles. Okay, then what do you do? But, okay, angle TSV is equal to half of, okay, angle, okay, TOQ. My professors, I hope you are following.
Yes, please.
Yes, please.
All right. If someone can use T, okay, it's the same thing. Because someone can use TSQ, it's the same thing. Okay, it's the same angle that you are talking about. Okay, so it means my angle TSB will be equal to half of what? The angle 56 degrees. And that was the one that gave us what? The 28 degrees that we have there. Okay, so I can say that therefore my angle TQP, what I'm looking for is equal to 28 degrees. Alpha. So Alpha. My professors, are you there? Hello, are you there?
Yes, please.
Yes, please.
Okay, then I. Okay, what are we looking for? We are looking for angle QTS. QTS, this angle. Oh, okay, so that would be a cool chop basically. Okay, so you know the interior, this is an interior angle to this triangle STQ. It's an interior angle. So it means if I'm able to get, okay, one of the interior angles, okay, another interior angle here, I know this. Okay, I know one of them to be 28 now. So let me see if you can find the small angle that is here. Is my point well made, my professors? Okay, so we did a whole lot of analysis, remember. Okay, so we said, let's see whether there is any other, okay, all right. So we said, okay, the angle here is 28. We are talking about this angle, we are saying it's 28. Okay, we also know that the angle here, the entire angle here should give you 90. Is that clear? My professors,
Yes.
are you with me? So the entire angle here from this line, which is OQ, to this line PQ, should be 90 degrees. Is that not it?
Yes,
Okay,
please.
however, you know this to be 28. So it means the remaining angle here. Okay, let me pick a different color and use the color to explain. So let me pick this. So the remaining angle here, this angle, okay, will be 90 minus 28. Do you agree? My professors, do you agree?
Yes, please.
Oh,
Yes,
someone wants me
please.
to come again. You agree, right? Because this plus this should give you, okay, 90 degrees, but you know this. Okay, so you are left with these two. But these two, you only need, okay, remember we only need this part. Okay, however, in this triangle, okay, do you know that you can find the size using this triangle? I won't present the solution because of time, so follow the analysis, then you put it in your own, okay, way. So this triangle here, okay, so the angle in green, the green angle there, so let me pick the green, then go and state its value there. So the green angle that we have there, okay, the green angle, this angle, the angle in green, okay, will be equal to, it will be 180 minus 56 divided by 2. That is the base angle of that isosceles triangle. Is that clear? So let me put it this way. So angle, okay, O, okay, TQ, okay, is equal to angle OQT. Okay, and it's equal to 180 degrees minus 56 degrees all over 2. What is your reason? Base angles of an isosceles triangle. Is that clear?
Monty, how do you get the 180 minus 56? I didn't get that part.
Oh, this triangle, we are looking at this triangle, it's an isosceles triangle with the base angle in green. This triangle, triangle TOQ. Can't you see that this is a radius, this is also a radius? So the length here will be equal to this length. So this is an isosceles triangle. You don't need the
Exactly.
rocket sciences to tell you that. So the base angles, once you know one of the angles, the base angle known. So that's why I said OQT. Okay, okay, so it's equal to OTQ, the base angle, and that will be equal to, okay, 180 minus 56 divided by 2, because you share, they will be equal. You get it? Afa, oh, you are not
Okay.
responding. Is that clear?
Yes,
So I
please.
didn't hear the explanation.
Can I what?
Please, were you explaining how you had the 180 minus 56 over 2?
Again, oh, there's an
I,
isosceles triangle. There's an isosceles triangle. So the base angles must be equal. Okay, so you subtract this one from 180, divide it by 2, then you share. So that will be the size of the angles in green. Angle OTQ, which is the whole of this angle, should be equal to angle OQT should be equal to angle OTQ. Okay, because you are looking at this as your isosceles triangle. So if I give you this triangle, this is 56 degrees. Okay, then this is O, okay, this is T, this is Q. And I ask you to find this angle and this angle. You can't find that angle. Okay, where you know that this side is equal to this side. The lines are basically to confuse you. So take the one that will confuse you out when you are doing the analysis. So this line here is basically to confuse me because my triangle that I'm looking for will be made by these lines. So when I'm doing, I won't consider it, it will be here. You get it?
Yeah.
So how do you get it? The sum of the interior angles, so it's if this is x, it will be x, okay, plus 56 is equal to what? 180. So you are going to get 180 minus 56, which will give you 2x, then you divide by 2. So that will give you each. That's what I have here maturedly. Afa,
Yes, please.
are you sure? Your yes is
Yes,
not that convincing to me.
yes, please.
Is it?
Yes, please.
Okay, all right. Okay, so, okay, where did I even get to? Oops. Okay, so we're looking for Q, okay, QTS, so Q, okay, TS, okay, so we are looking for this angle. Okay, so the angle there. Then I said if you're able to get this interior angle here, you know this. Okay, so that's basically all that, okay, we are, okay, doing. But you should know someone can also choose to be smart. Okay, you know that someone can find this. Okay, you let me go by, someone can find this angle. I can find this angle. Okay, because I know this is a triangle. Okay, so I will subtract the sum of these two angles from 180, and that will give me one part of what the angle that I'm looking for. That's why I said you have a whole lot of ways. So it means I have to also come and find another part. So I know this angle. Okay, so if I know this angle, I think I know this angle. Okay, if I can find the angle here, then I should know the small angle here. But if I know the small angle, basically I know this. So let's go and find the small angle. That is what is left. Okay, the whole of this, we said, oh, have you done this calculation? Give me the value. I will use it to find a small angle here.
62 degrees.
62. Okay, so that will be equal to 62, okay, degrees. So the angle in green is what, 62 degrees. Is that not it? Are you with me? So it means if I know the small angle here, please take note. This is going to be the last statement that I will make. Then we are done. Okay, let me pick. Okay, should I pick which color? Okay, so let me pick this. Okay, if I know the small angle here, let me come and bring it here. If I know the small angle here, I know this angle. Is that not it? Because the sum of the green is made up of the small angle and the small angle. Is that clear? Oh, you can't see, so let me use the green is made up of the entire angle here, which is this angle plus this angle. Do you agree?
Yes.
Okay, so if I'm able to find this angle, okay, and I know, okay, the entire angle here, remember the angle in green, I know all of them. I subtract it from this, then it will give me the small angle that I'm looking for. Then I will come and find it. So I will just help you analyze. I can use vertically opposite angles. I can use vertically opposite angle to get this. This is 109. Do you agree? Do you agree that this angle is 109? This angle, vertically opposite angles. Do you agree?
Yes, please.
Okay, very good. So respond because we don't have time. I've gone beyond my okay 1 hour. Then if I know this angle, I can consider the triangle here. Let me use the triangle VOQ. If I consider the triangle VOQ, then I know the small angle. The small angle here, which is this one, will be okay 180 minus 56 minus 109. That will give me the small angle here. Is that clear?
Yes, please.
I hope you are with me. So once I know the small angle, you subtract the small angle from the entire angle here, which is the 62, then you know this angle. So once you know this angle here, okay, you come and add this angle to this angle, subtract it from 180, and that will give you the angle that you are looking for. That is one way. You can do a whole lot of analysis too. Is my point well made? Okay, someone can also do this. Okay, you know the size of this angle to be 28. Okay, so listen, you know the size of this angle to be 28. We found this. You know this to be 56. You know the entire angle here to be 90. This entire angle. So I know this angle. Do you agree? The angle here will be 56 plus 90. Subtract it from 180. That will give you this angle. Is that clear? My professors, are you
Yes,
with me? If you consider triangle POQ, this is 90. This is, the other interior angle here. You are left with the add, you subtract it from 90, and that will give you the angle that is here. Once I know the angle that is here, remember, if I take this triangle PTQ, okay, I know two of the interior angles, so I can find this angle. Is that not it? Once I'm able to remember, already we found this. If you are going the separate way, the angle that I told you that this one will be, this, subtract it from 180, and that will give you the angle that is here. Okay, add this to this, subtract it, that will give you the angle here. And again, okay, if I know this angle, angles on a straight line will give me the other angle that I'm looking for. So the entire angle here will be the size of this angle plus this angle. I'm done. So you have various ways that you can do your analysis, provided, okay, you are well grounded in terms of your properties. Is my point well made?
Yes.
Okay, so Prof. Akosia,
Dr. Man, please can we do this presentation to the end? Because after the 62, I still don't get how you find the small angle there.
after this 62,
Yes, please.
oh, so you want me to write? Okay, please, I don't want any excuses. You write the test. Okay, the test will be, it's like a full-blown exam, so it's 2.5 hours. Okay, so if it eats into, I don't want any excuses. I'm going to give you the presentation. Okay, if you want to follow. So this is it. Okay, we've done the analysis together, but okay, so already, I don't know why this should be, I should belabor the point. Okay, because let me see. Okay, so we said we have found the angle, what? Angle T. So I know the angle, okay, OTQ, okay, is equal to angle OQT. Okay, and that should be equal to, okay, 180 degrees, okay, minus 56 degrees over what? Okay, 2. Okay, so I'm going to clear this, then I'll write my reason there. If you want me to write it, oops, okay, I thought I've saved it. If I've saved it, then clearing it, or maybe this one has been saved. Okay, it has not. Okay, so at least I have created a room, so let me go and do what I want to do. So I put my reason in bracket, and that will be, okay, base angles of, okay, triangle O, okay, so OTQ. Okay, and that is an isosceles triangle. If you like, you can write isosceles triangle. Is that okay? Is it okay? Prof. Akosia, you said I should
Yes.
write. Is it okay? So respond in, okay,
Yes, please.
so which will give us what? We said it will give us 62, right?
Yes, please.
Okay, so 62 degrees. So it means, okay, this angle here, the entire angle here, okay, will be 62. So okay, so I know this to be 62 degrees, the entire angle here, okay, to be 62 degrees. Okay, and remember, we said we can equally come and find the small angle. The entire angle here is 62. We can come and find the small angle. If I'm able to find the small angle, then I'll subtract it from 62, then I'll get the remaining angle here. That is the angle I'm looking for. So on that note, I am going to, okay, create another, okay, slide. Drawing my attention. Don't worry, it's pressure that Akosia is giving me, that's why. All right, okay, so this is it. Okay, so we said If you're able to find a small angle, okay, that's the angle here, then I know the angle here which I'm looking for to find this, because I said when we planned, we said we know one of the interior angles of this triangle. So if I'm able to find this interior angle, then I will know that. I will know the one that I'm looking for here. Okay, so in this case, how do I find this angle? This angle, small angle here, is one of the interior angles of triangle VOQ. Akosia, do you see that? VOQ. Do you agree that this angle here is one of the interior angles?
Yes, please.
Okay, so this triangle that I'm looking at, already one of the angles given, which is this. But if I study it carefully, the other angle here, which is here, is vertically opposite to this. So I can say that angle VOVQ is equal to angle. Okay, this one was given in the question. I want to go by what you have there. In the question, it is SVP. Do you agree? So I'm going to write it that way. Angle OVQ. Let me move on to the next slide. Okay, but angle OVQ, okay, is equal to angle, okay, the one TSVP, and that should be equal to what? 109 degrees. What's your reason? Vertically opposite angles. Is that clear?
Yes, please.
Okay, all that I'm writing, I've said it all. Okay, so it means I know this to be 109. So if I know this to be 109, then I know this angle, small angle here. Okay, so angle, okay, what do you call it? Oh, this implies that angle O what? Kelvin. O, okay, Kelvin, okay, will be equal to, remember it will be 180 degrees minus this angle, which is 56. So let me write it in terms of the vertices, minus angle, okay, S. I'm using this triangle, so let me go strictly by what you have there. So minus angle VOQ. Okay, then minus what? Angle, okay, this angle, which is what? Your TV, okay, what do you call it? It's OV, okay, Q. And I wrote what? VOQ. Okay, but VOQ is what I have there. Let me come. Angle OQV, OQV is equal to 180 minus, okay, angle, this angle and this angle. So angle VOQ, I've done VOQ. Then minus angle, this angle, angle OVQ. Okay, so OV, angle OVQ. I hope you get my point. Hey, OVQ na natural then. No? Angle OVQ. Okay, this is what you have there. Okay, because you are dealing with also it to be angles in a triangle. Is that clear, Akosia?
Yes, please.
Okay, so my angle OVQ will be equal to 180 degrees minus VOQ. VOQ is 56 degrees. Okay, minus OVQ. OVQ is 109. That's what you found here. OVQ, 109 degrees. So I'm waiting for your answers. Quickly.
15 degrees.
15.
Yes, please.
Okay, so 15 degrees. So that's the size of what? This angle here. Okay, but you know, okay, but, okay, I know that my angle that I'm looking for, which is this small angle here, which I said if I'm able to get it, then I know this angle here, okay, which is angle, let me use angle, is it, which angle is up here? Let me remove this one from there so that it will be clear for me. Okay, so S. Okay, so angle S, okay, Q, SQ what T? Angle SQT. We know will be equal to, okay, the angle SQT is the whole of what we have here. It will be the entire angle here, then minus this angle. So it will be angle OQT, angle OQT. okay, minus angle, the small angle that we found here, O, okay, Kelvin, O, Kelvin. Is my point well made?
Yes.
Okay, so that will be equal to angle OQT. We found angle OQT. Where is angle OQT? Did you where is it? OQT is here. That is the 62. Can you see that?
Yes, please.
So that will be 62 degrees minus what? The angle OVQ, and that is here. OVQ is 15 degrees. Okay, so that will be equal to, okay, here I'm waiting.
What's the please?
Okay, so 47 what degrees. So once you know this angle, okay, you are more than, but you know. So let me squeeze it here. I think I created another one. So I'm going to write this angle that we are looking for, which is angle QTS. Okay, okay, angle, but angle QTS will be equal to 180 degrees minus, I'm looking at that interior angle, minus angle, okay, this angle here, the angle up here, which is TSQ, angle TSQ, then minus what? The small angle that we just found, which is SQT, angle SQT. Okay, so therefore, my angle, okay, QTS that I'm looking for will be equal to 180 degrees minus angle TSQ that gave us 28 degrees. Okay, minus angle SQT, that's the one that we just found. Okay, and that is what? 47 degrees. Okay, and that will give you the answer that we are looking for. And I went another route. Okay, finding this angle. If you know this angle, you know this angle, you can find this angle. Once you find this angle, you know, okay, angles on a straight line, you can find one of the interior angles of the triangles that you are looking for. It's now in two parts, this part and this part. So this part, you use the angles on a straight line, considering this triangle. Okay, and this one, you use the interior angles of this triangle. Because you know this, so you have found this. So a lot of ways. You get it. If you like do it, you end up getting the same result.
Yes,
Offer. Hello. Are you okay?
yes, please.
Okay, so on that note, okay, so what did we get? Now that I've done it, I have to give me the final answer. So that I know that I solved the question in full. Final answer.
105.
105, okay, degrees. Okay, don't forget your degrees in anytime you indicate the values. Okay, so now I think, oops, this takes us to, okay, this one I will just analyze. You can see that this one too is similar to, okay, you can see a tangent, you have a tangent and you have a triangle sitting on it. Okay, take notes. So once you see that, you shouldn't be a person. I'm only going to analyze, I won't write. Don't force me to write, please. Okay, but if need be and you are not following and I have to write before you follow, please don't worry about me at all. I'm here because of you. Okay, so all the information here, let's see if there is any, okay. So we are told that a vital information, the line TC bisect triangle, oh sorry, angle BTQ. So BC is, okay, the line BC, which is it line BC, line TC bisect this angle, okay, which is angle BTQ. So it means the angle here, if let's say this is X, this will also be X. Do you agree? My
Yes.
professors, I hope you are with me. So that is an extra information, okay, which the what the diagram they didn't bring out that picture, but it's here, so you have to consider that. So this is all that we are going to do. Can you see a triangle sitting on your, okay, or on your tangent with all the vertices at the circumference? Can you see that?
Yes.
Okay, triangle ABT. So it means we can use the alternate segment. So if you look at the alternate segment, okay, if you take this chord, okay, this is the angle between this chord here. Remember, I've told you the triangle sitting on it with all the vertices at the circumference. That's the what do you call it? the circumscribed what triangle. Okay, please take note. Okay, only two of the chords will meet the tangent. So this chord is meeting the tangent at an angle of 60. So that chord will be equal to the angle here will be equal to the angle that chord subtend at the circumference. So it means if for nothing at all, I know that this is also 60 degrees. That's the angles in the alternate segment. Is that clear? My professor, is my point well made? Okay, then again, I know that the other chord that is making an angle with a tangent is this. Okay, and that is making the entire angle here. So if I know this angle between the tangents, okay, and the chord, okay, I should know it should be equal to the angle this chord subtend at the circumference, which is 44. So it means the entire angle here is also 44 degrees. Is that clear? Alternate segment angle. My professors, I hope you are following.
Yes, please.
Okay, now let's look at what we are asked to find. And we were just exploring to get what you have there. So here, what do we have? We are told, okay, that we are asked to find angle ACT, ACT. So AC, okay, let me remove this one from here. Okay, AC, okay, T. So I'm finding this angle. Oh, this one is easy peasy. Okay, so if I'm able to find, okay, this interior angle here, okay, indirectly I know that, okay, because the entire angle here, I can use the entire angle here plus this entire angle, subtract it from 180, and that will give you this angle. But once I know the triangle ABT, once I know this angle and this angle, I know this angle. Do you agree with me? I add these two, subtract it from 180. My professors, I hope you are following. Okay, so once we said that the whole of this is 44, and we know that this line bisect this angle, then we know that this is 22, this is also 22. Is that clear? Is that okay, my professors?
Yes, please.
Oh, what is happening now? I'm responding in time where, please, okay, make sure you unmute. We are talking, so unmute. Don't wait for me to ask you to unmute before, so that when you talk straight away, I will hear you. Okay, so in this case, this is 22. Okay, I'm able to find this angle, which will be 104. Okay, I subtract it from 180, and that will give me the size of this angle if I'm considering the triangle ABT. You get it? My professors, are you there?
Yes, please.
Okay, so triangle ABT will be equal to, sorry, angle ATB will be equal to also angle, let me just write angle A, okay, TB or BTA will be equal to 180 degrees minus what, 44 degrees, then minus 60 degrees. Is that clear? Angles in a triangle. So once you know this angle, you are in a comfortable lead because the angle that you have here will be equal to 180 minus 44 minus this angle minus the 22. Because if you consider the entire triangle here, okay, it will be made up of the angle here, which you know this angle and you know this. So this plus this plus this, you subtract plus this should give you 180. So you add these three, subtract it from 180, and it will give you, you add this, this, and that, subtract it from 180, and that will give you this. Afa, point well made, my professors. Hello, are you there? You are not responding, no. What is, or you want me to write it?
Yes, please.
Okay, no problem. Okay, so don't worry. Okay, so let's see. Okay, so solution. Okay, so we said, okay, we were able to find the size of this angle. Okay, angle, okay, ABT, okay, will be equal to angle Okay, ATP. Let me see whether that was what they use PTA. So I want to go by the labeling, but it doesn't really matter. It's the same angle that you are. And okay, that is equal to 60 degrees. Okay, what is your reason? Alternate segment angles. Hope you are following now.
Yes,
Those
please.
who are happy, I'm writing. Okay, all right. So now let's see. I should have known that if I put it into writing, maybe. Okay, from the beginning, alternate segment angles. Okay, so now what do we do again? We are able to find this angle based on the alternate segment angle. So I can also say that, okay, angle BTQ or TQTB, okay, will be equal to angle ABT. Okay, so angle, no, BAT, but okay, let me see whether, okay, that was how it was. Okay, and that should be equal to 44 degrees. Okay, it's the same property, so you can choose not to write it. Okay, otherwise alternate. Okay, it's the same thing. So you don't repeat alternate segment angles. Okay, then now we know that, okay, if I want to find, I know this angle, okay, I know one of the interior angles here. So if I'm able to find the size of this angle here, I'm good to go. That is one way. I will teach you another way, okay, after this. So if I know, okay, the entire angle here, I am more than good to go. Okay, so how do I get the entire angle here? Okay, so the entire angle here is made by angle ATB. Okay, so I'm going to say that angle, but okay, so angle A, okay, TC, we know is equal to, it's made up of two angles, angle ATB plus angle BTC. Do you agree?
Yes, please.
Okay, very good. Okay, so let's see if you can find any of them. Okay, so ATB, I can find ATB. Okay, but I'm taking ATB, and the ATB, okay, is equal to one of the interior angles here. Okay, and that would be equal to 180 degrees minus what? 44 degrees. Okay, then minus 60 degrees. All correct. Okay, so give me the value and let's go. Okay, I'm going to write it here because of space. Okay, I don't want to create another. Okay, so give me the value and let's go. Usually, you know, you should calm down. I'm waiting. My professors, hurry up.
76.
Okay, 76 degrees. Okay, if she's right, I'm also right. Okay, I'm not looking at the figures at all, so I haven't done that calculation. So now that will give us 76. And your other angle here, angle BTC, okay, we know is equal to angle BTC, which is BTC is equal to half of, okay, angle BTQ, which we know. Okay, so that will be equal to, okay, so let me write it here for lack of space. Otherwise, you come down. So that will be equal to half of angle BTQ. You found it, and that was what? 44. Okay, degrees. Afar. BTQ is here, 44 degrees. So that will give us 22 degrees. Is that clear? But please don't do this. So you remember I've told you, don't avoid writing more than one equal to on the same line. So you will calm down. Okay, so at that point, I can say comfortably, say that, listen carefully, my angle ATC, so this implies that my angle ATC, okay, will be equal to angle ATB, which is 76 degrees, okay, plus angle BTC, which is 22 degrees. So give me the value. I'm waiting. 98. Professors, are you there?
Yes, please.
98 degrees. Okay. So now, once I know this angle, okay, I know this angle. So my final statement will be, okay, therefore, my angle ACT, angle ACT, okay, will be equal to, let me move this one up. Oops. Oh no, I wasn't looking for. So please come up. I'm not looking for. I want to move you up. Okay. So that will be equal to 180 degrees minus, okay, 44 degrees, the other angle there. So minus 44 degrees. Then minus this angle that we found here, which is the angle ATC, and that is 98 what degrees. So whatever that you get becomes what your answer. As simple as that. How far?
Yes.
Is my point well made, my professors?
Yes, please.
Okay, very good. So if that's the case, then I think we've done justice to, okay, the circle theorem, okay, questions. Okay, that came in the WASSCE 2020-24 Nigeria. Any questions? Okay, I think I've seen a hand up. Let me see who the person is. Okay, Prof. Ann.
Please, the theorem that a tangent makes 90 degrees with a chord, please.
No, with
In this case, what would the
it's
90
not with
be?
a chord. With a tangent makes an angle of 90 degrees with a radius, please.
Okay. Thank you.
All right, with a radius, not with the radius and the tangent that will meet at an angle of 90. Okay, Prof. Ann, have you subscribed to me? I think he said yes. Okay, I have circle theorem questions there. Okay, please go, especially the class test questions. Okay, watch that
Yes,
video before you
please.
go back to, okay, it's cool. I don't think you can watch the entire lesson on circle theorem.
Okay. Thank you.
You're welcome. Okay. All right, so are we fine? Okay, so are we set to write the test? Are we all okay now? I
Yes.
think we should be. Okay, so on this note, I would want to say if you don't have any further questions, anything to say, okay, we are going to call it a class. So we are done for today. Okay, we thank God for a successive and very interactive, okay, class. God bless us all.